3.5, number 197. It says find all x on the graph of this function, f of x equals negative 3 sine cos where the tangent line is horizontal. All right, if the tangent line is horizontal, that means the tangent line has a slope of 0, i.e. tangent has slope 0. Well, if the tangent line has slope 0, then that's going to imply to us that f prime of x should have a value of 0, right? Slope of the curve is the slope of the tangent line at the curve there, so if the slope is 0, then the derivative must be 0. Again, a very important problem throughout the rest of the course, finding where the slope is 0. So we need to set f prime of x equal to 0 and solve. So f prime of x will be negative 3 sine x cos x with the derivative taken. Okay, so again, you have a constant multiple out here, and you've got a product of two functions. So the derivative will bypass the constant multiple, and it will apply itself to this product of two functions using the product rule. So the first times the derivative of the second, derivative of cos is negative sine by memorized fact, plus the second times the derivative of the first, derivative of sine is cos, again memorized fact. All right, so there's the derivative taken. Try to clean up a little bit because we have to set equal to 0. So we have negative 3. We'll have negative sine squared plus cos squared. I'm just going to write it in the opposite order, so I'm subtracting. So we'll have cos squared x minus sine squared x equal to 0. All right, so the problem with this equation and solving it is that you have two different trigonometric functions in the same equation. Usually that's not advisable. Usually you like to have one trigonometric function only represented there. So there's two ways to go about this. This, it turns out, cos squared x minus sine squared x is the same as the cos double angle. It's cos 2x. So we could deal with this by rewriting this as cos 2x. There's another way to deal with it, and that is using the Pythagorean identity. Sine squared plus cos squared is 1. All these identities are highly related. It's 1. So I could replace the cos squared here, right? Cos squared must be 1 minus sine squared. So that's another way to deal with it. Either way, we'll be left with only one trigonometric function. If I use the first possibility, this identity here, then this is replaced completely with cos 2x, and now I just have a cos function to deal with. That's fine. It's a double angle, it's true. It doesn't make it that much trickier though. Over here, if I replace cos squared with 1 minus sine squared, which is actually what I'm going to do right now, then I'll be left with only the sine function in this equation and no double angle. So I'll just do that. I'll just replace the cos squared with 1 minus sine squared due to the Pythagorean identity that we're all familiar with. At this point, I'm going to combine the two sine squares into 2 sine squared. So negative 3 times 1 minus 2 sine squared x equals 0. Okay, the only way this is going to be 0 is if this part is 0, of course. Negative 3 cannot become 0. So I'm not worried about that. So it now devolves into 1 minus 2 sine squared x equal to 0, and this is the equation we really need to solve. If we subtract 1 from both sides and then divide by negative 2, we end up with sine squared x equals a half.